So we have two more examples here. So you would type them into your calculator. So y equals x squared, and I'd just usually adjust as I need it, delete what I need and type over what I don't need, so I don't spend a lot of time retyping everything. Okay, so there's my graph, and I need to find my x-intercepts. So I could estimate and say, gosh, that really looks like it's at -2, and just type trace and then -2 to see if I'm right. And then I notice I have a 0, so I'm right. I know one of my solutions is -2, 0. And then I come over here and go, gosh, that really looks like it's going through +3. So just type 3. Yep, I'm right. It is going through 3. So the x-intercepts are -2 and 3. And I didn't have to go through any of that work. So I can just go ahead and graph what it looks like. Looks like something like that. -2, 0. Notice I didn't ask about the vertex. I didn't ask if it was a min or a max. I didn't ask about the y-intercept. We're just solving them. And my solution is x equals -2 and 3. So I want to see your graph and I want to see your solution for these problems because we're solving by graphing. Example 2. Move this over here. Go back and type it in. Now, second insert will let me add a negative in front of that without having to go back and retype everything. And then I want plus 4x minus 1 graph. There's my graph. And this time, gosh, it doesn't cross at 0 and it doesn't cross at 1. Maybe it crosses at -1/2. So you do trace, or not negative, but a half. So you do 0.5, and I'm wrong. It's not 0 this time, so it's not a half. It has to be smaller than that. Maybe it's 0.4. And you can see I got closer. Maybe it's 0.3. And I'm really close. Maybe it's 0.2. Oh, now it's negative. So I could keep guessing, but why keep guessing? Let the calculator do the work. So second, calculate. Its number 2 is the zeros. And make your bounds. I need to be to the left of this point. I'm going to go a little farther so I can actually see it. So hit enter. Then I need to arrow over to the right of it. And now I gave my little window of searching. And enter. And you can see it's 0.26794919. No repeating here. There's nothing that's being repeated over and over. So I'm not going to round significantly, but we are going to estimate this. This is not a nice decimal or integer. It's not a half, it's not a third, it's not a quarter. And that's because it's an irrational number that we're getting, and that'll make more sense as the chapter goes on. But we're just going to estimate. We're going to give an approximate value. So 0.2679. I'm going to ask you to round to the hundredths place. And then we need to do the same thing over here. So we're going to go back, second, trace. We're going to do a 0. And yes, this is to the left of this one, but let's not give the calculator, let's make the calculator's job a little bit easier. That's a big window. So try and make your window fairly small for the calculator to search in. That will help give you a more precise answer. And then this time, this one's 3.7320508. Again, it's nothing is repeating. It's not 3.222224. Okay, that you would round to 3.2 or 3.2 repeating or something like that. But this is not. So we're going to round to the nearest hundredth. We're going to give an approximate value. So then you would go ahead and graph it. Sorry about my sloppy graphs. This would be 0.27. This would be 3.73. And then you would say x is approximately, because it's not the exact answer, we rounded it, 0.27 and 3.73. And those are approximate answers for that solution. Later in the chapter, you'll find out how to find the exact answer, because an approximation sometimes isn't good enough, but for what we're doing and for just learning it, it will work.